all intelligent life in the universe will die. All the tears and all the struggles and all the heartbreak of humanity since we rose from the swamp, it's all for nothing.
Some believe the universe will end up in fire. Others think it's the ice that will dominate. What exactly is the fate of the universe? There are hundreds of thousands of cosmic and non-cosmic possibilities that could wipe out life on our planet. It could be an asteroid impact, rogue black holes, a volcano eruption, or even killer robots. However, the chances of Earth going through an unprecedented global catastrophe are very slim. But we know that the ever-changing climate and a constant increase in the sun's intensity are calling for an end. Yet, things are not as simple as they look on Earth. Predicting the beginning and end of the universe has been a bit tricky for scientists, but they have never stopped to speculate and theorize about what's coming next. From naming the Big Bang as the beginning to predicting the end, scientists have speculated on multiple theories to determine the ultimate fate of the universe. Whether it's lying in the fire in ice or it will end up in a bubble, scientists have left no stone unturned. Join us in this video as we delve into what exactly the fate of the universe is, which theory predicts it the best, and what we should believe in. Let's start from the beginning. The scientific exploration of the fate of the universe started in 1915 with Albert Einstein's theory of general relativity. His theory provided a framework that could be employed to describe the universe. Einstein's equation described the structure of space and time and suggested that the universe is not static. It ought to be expanding. In 1922, Alexander Friedmann proposed solutions to depict that the universe had been expanding from an initial singularity, which was still unknown. A few years passed, and nobody believed in Einstein's idea of an expanding universe until Georges Lemaitre, a Belgian cosmologist, appeared on the scene. He was the first to postulate that the recession of nearby galaxies could be explained by an expanding universe. Then, in 1948, Edwin Hubble, an American astronomer, proved that Georges' theory was correct, and that the recessional velocity of a galaxy rises with its distance from the Earth. This also suggested that 13.8 billion years ago, the universe started off highly dense and has been expanding and getting less dense ever since. The later works proved that the universe started with a Big Bang, which we call a singularity, and has been expanding continuously.
Between 20 and 22 billion years from now, if the cosmic acceleration goes unchecked, the world will end in a big rip.
Wow. What could possibly check it?
Not with a bang, but with a rip.
But the question is that the Big Rip is the only possibility of how the universe will end. Well, scientists have proposed different hypotheses for it, starting from the Big Crunch to the Big Chill and even Big Bounce. Here in this part, we'll dive into each scenario and know exactly what the fate of the universe would be. The Big Crunch. This hypothesis is a symmetric consequence of the Big Bang theory. The believers of this notion state that the expansion of the universe doesn't continue forever. There would be a time, not in the near future, but probably in 1 trillion years, when the average density of the universe would be enough to stop the expansion. The cosmic bodies will start disintegrating, the lurking galaxies will smash into each other, and all the matter and life existing in space will contract into one dense state, maybe a state from where time began. Scientists claim that this dense state of the Big Crunch can allow the Big Bang to occur immediately, and if this process of a bang and crunch is repeated over and over, it will create an oscillatory universe. This basically means that the universe would consist of an infinite sequence of finite universes, with each finite universe ending with a Big Crunch, which is also the Big Bang of the next universe. But there's a problem with accepting this model as the ultimate fate. The Big Crunch model doesn't follow the second law of thermodynamics, and it is based on the assumption that the universe is closed-shaped, but current evidence shows that our universe is not closed. So the Big Crunch model is still a hypothesis that requires lots of work to become the ultimate fate. As Stephen Hawking stated, everything will become so far apart that even gravity will be defeated. I think a big chill is what we've got in store, not a big rip. Big chill. It's another popular model for the fate of the universe. The big chill is a scenario under which the universe is driven by dark energy to expand faster until a point where the distance between galaxies becomes infinite and the temperature reaches absolute zero. It's a state where you'd walk out in the night and see no star in the sky. Everything is blacked out. Scientists have not yet discovered what dark energy actually is, but they do know that in space there exists some strange energy that's stronger than the gravitational pull between galaxies, planets, and stars. This strange energy is the main culprit behind the continuous expansion of the universe, and in the distant future, there will come a point where this energy will dominate space. Eventually, all the space bodies would be so far away that the stars would lose access to the raw material that is needed for star formation. The existing stars would be exhausted, and new ones would never form, so the light would be gone forever. The expansion would push the stars and galaxies to an infinite distance, which eventually makes the universe colder and colder until the entire universe reaches absolute zero. At absolute zero, there's no movement and no heat, so nothing can exist at all. This eternal expansion and absence of light and temperature would freeze out the universe, resulting in a depressing end to time or the ultimate heat death of the universe. The big chill would make the very last star in the sky wither out. Big rip. This model is also based on the accelerated expansion caused by the dark energy. The hypothesis relies on the assumption that the expansion effect of dark energy will be so strong that the space bodies, including our planet, neighboring galaxies, stars, and space matter, will no longer hold themselves together and ultimately rip apart. According to this model, dark energy will become stronger and stronger over time. It will dominate and distort everything, and you will have nothing in the universe. According to Robert Caldwell, a theoretical physicist from Dartmouth College, the Milky Way will get stripped roughly 60 million years before the Big Rip. A few months before the end of time, the Earth will be ripped from the Sun, and almost 30 minutes before the end, the Earth will fall apart. Big slurp. When all the former scenarios felt a little wacky, scientists proposed a new possibility that could possibly predict the end of the universe. This theory is based on a recent discovery, a discovery that forced a theoretical physicist from the Fermi National Accelerator Laboratory in Batavia to claim that if you use all the physics that we know now and you do what you think is a straightforward calculation, it's bad news. So what is the bad news? Well, recently physicists from the European Council for Nuclear Research, CERN, announced the incredible discovery of Higgs boson particles. These elusive particles give mass to almost all other particles, including our planet, galaxy, or even the universe. The particles were observed under the Large Hadron Collider in Switzerland. David Miller, one of the many University of Chicago researchers who have worked on this discovery, stated, "The Higgs is fundamentally related to key aspects of the universe. It was wonderful and amazing that we were able to discover it." The Nobel Committee wrote, "We do not notice it. The Higgs field is like air to us, like water to fish. But why are Higgs particles so important? And how are they related to the ultimate fate of the universe? If the Higgs boson particle weighs in at a certain mass, it could indicate that the vacuum of our universe may be inherently unstable, existing in a perpetual metastable state." Physicists Michael Turner and Frank Wilczek suggested this unpleasant scenario. Without warning, a bubble of true vacuum could nucleate somewhere in the universe and move outwards at the speed of light. And before we realized what swept by us, our protons would decay away. If the protons in all matter in our universe decayed, so would mankind. And then, just with a slurp, everything in the universe will vanish, leaving behind a bubble, an unpleasant, mysterious bubble. The Big Bounce. Considering all the models that profoundly support the Big Bang Theory, some scientists proposed a new approach that could possibly predict the end, or even deny the beginning. The scientists gave a whole different approach, the Big Bounce Theory, also known as the ekpyrotic model. It suggests that the universe has no beginning or end. Instead of a bang, what happened to the universe was just a bounce. Big bounce. a moment at which the universe was contracting to an infinitely small point. It just bounced to expansion. The theory is derived from the oscillatory universe of the Big Bang, which states that the collapse of a previous universe led to the first cosmic event. In a broader view, the cosmological Big Bang theory holds that the universe was initially infinitely dense. Such a description appears to conflict with other, more established theories, particularly quantum mechanics and its uncertainty principle. Thus, the Big Bang idea has been challenged by quantum mechanics, which suggests that before growing in a manner governed by conventional physics, the universe first delved into existence with a finite density consistent with quantum mechanics. Furthermore, if the universe is closed-shaped, then the Big Bounce predicts that once this universe collapses, it will give rise to a new universe in a phenomenon similar to the Big Bang, after a universal singularity is reached or a repulsive quantum force causes re-expansion. So according to this theory, the universe will perpetually go through a cycle of a Big Bang followed by a big crunch. Each possibility for the end of our universe is based on a simple form of dark energy. However, very little is known about its physics and properties, so having blind faith in one of these theories would not be the best option for now, as frequent work in the realm of dark energy and quantum physics is required to accept a certain theory of the end. Till then, we can only speculate and look forward to the new hypotheses and theories.